Tomorrow exam is there. Tomorrow morning 78 exam login time. Already message came na? Subankar? Why again asking? It was conducted on Sunday before. As per track sheet, na? As per track, Saturday is exam and Sunday is advance. Because of Monday onwards, half yearly exams. Right. Miscellaneous open determinants. Miscellaneous. Okay. Now I explain in miscellaneous. Okay, at third year. All are complete miscellaneous determinants. Or explanation required. Ashit Kumar, Bhagirath, Jyoti Prakash. What no, sir? Explanation not required. At third year. Vidkant, all are done. Okay. Priyank, Subhankar Sahu. Anyone want miscellaneous, determinant miscellaneous? All are complete, Bhagirath. Okay. So now what to do? Determinant examples. Determinant examples. Complete or not? Now start examples. Determinant examples. Continuity chapter. Alright, continuity not complete. Okay, tomorrow evening discuss study our time, continuity. Continuously and differentiability concept. Only continuity one exercise, na? Differentiability there are only two problems only. Differentiability there are two problems. Okay, today complete remaining chapter. Tomorrow evening explain continuous. So now determinant completes examples. Then set open and set in. See page number 115. Page number 115. From example 11, 12, 13, 14, yes, up to 16. From 11 to 16 practice. Example 11 to 16. These examples anyone complete? Okay, Jyoti Prakash complete. So now you start continuity. Color complete examples. Explanation any required? Any problem? Tell doubts. Okay. Ask the doubts any chapter. Say limit continuity concept is, say once I explain concept. See continuity will mean limit f of x extends to a. Listen, Jyoti Prakash, Bhagirath. Limit extends to a, limit f of x extends to a is equal to f of a. Then f of x is continuous. F of x is continuous at x is equal to a. Limit f of x extends to a is equal to f of x. Okay, this condition is satisfied, then f of x is continuous at x is equal to a. And limit f of x tends to a f of x is not equal to f of a. Then f of x is discontinuous at x is equal to a. Discontinuous at x is equal to a. And next, limit x tends to a minus f of x is equal to limit x tends to a plus f of x. So left limit is equal to right limit, that is equal to f of a. So this is also f of x is continuous at x is equal to a. Then f of x is continuous at x is equal to a. So not equal, left limit is not equal to right limit, this is discontinuous at x is equal to a. Understood? So this is called LHL, left hand limit, and this is called RHL. Both are equal, it is continuous. LHL is not equal to RHL, it is discontinuous. Understood? When x tends to a minus, see this point. When x tends to a minus, put x is equal to a minus h. When x tends to a plus, put x is equal to a plus h. When x tends to a minus, put x is equal to a minus h. Understood? See one problem. Exercise 5.1. See one problem. Sixth one. F of x is equal to 2x minus 3. 2x plus 3 if x is less than or equal to 2. And 2x minus 3 if x is greater than. So first LHL find. LHL means this is 2 minus. X is less than 2 means 2 minus. So limit extends to 2 minus f of x. So limit extends to 2 minus. What is f of x below 2? 2x plus 3. 2x plus 3. So now put x is equal to 2 minus h. Put x is equal to 2 minus h. As x tends to 2, as x tends to 2, h tends to 0. Okay. So limit h tends to 0. Limit h tends to 0. So 2 into 2 minus h plus 3. 2 into 2 minus h plus 3. So h tends to 0. So 2 into 2 minus 0 plus 3. 7. Okay, that is LHL. And RHL, limit x tends to 2 plus f of x. About 2. About 2 value is 2x minus 3. So limit x tends to 2 plus 2x plus 3. So now put x is equal, put x is equal to 2 plus h. As x tends to 2, h tends to 0. So limit h tends to 0. 2 into x value, 2 plus h plus 3. So now again h is equal to 0. This is 2x minus 3. So 2 into 2 minus 2 plus 0 minus 3. 4 minus 3 is equal to 1. So let LHL is equal to 7 and RHL is equal to 1. So LHL is not equal to RHL. Therefore f of x is discontinuous. F of x is discontinuous at x is equal to 2. F of x is discontinuous at x is equal to 2. Okay. You understood? Jyoti Prakash. Next. Yes, as per board level mathematics paper. And fill in the blanks. Fill in the blanks, sir. That is as per blueprint. That is 50 marks now. 10 questions, sir. Fill in the blanks. And 2 marks, 4 marks, 6 marks. Yes, upload the paper. Write on paper and upload. Yes, subjective type questions are there. Definitions. What definitions? Four marks, 2 marks, 6 marks. Write down on paper and upload. Take photo and upload. Right, next. T27%. Find the value of k. The function f is continuous. The function f is continuous. So that is f of x is equal kx square. X is less than or equal to 2. 3. X is greater than 2. It is already given, it is continuous at x is equal to 2. So given f of x is continuous at x is equal to 2. So that is limit f of x, limit x tends to 2 minus f of x is equal to limit x tends to 2 plus f of x. 2 minus f of x is this LHL is equal to RHL because it is continuous at x is equal to 2. So limit extends to 2 minus f of x, k into x square. This value is 3. So now x tends to 2 minus. Put x is equal to 2 minus h. Put x is equal to 2 minus h. As x tends to 2, h tends to 0. Therefore limit x tends to 0, k into 2 minus h whole square is equal to 3. As h tends to 0, that is 4k is equal to 3. Therefore k is equal to 3 by 4. Okay. And also try 26. And also try 26. Same question, same model. 26 is important. F of x is equal to k into cos x by 5 minus 2x. If x not equal to 5 by 3, if x is equal to 5 by 2. So given f of x is continuous at x is equal to 5 by 2. At x is equal to 5 by 2 given condition. So take LHL and RHL is equal to find k value. Limit x tends to 5 by 2 minus k into cos x by 5 minus 2x is equal to 5 by 2 plus. So here there is no left limit and right limit. So directly take limit x tends to 5 by 2. F of x is continuous at x is equal to 5 by 2 means limit f of x tends to a is equal to f of a. This is condition, continuous definition. But f of 5 by 2 value is 3. So limit x tends to 5 by 2. K into cos x by 5 minus 2x is equal to this value is 3. Find k value. So now 5 minus 2x is equal to h. Let 5 minus 2x is equal to h. As x tends to 5 by 2. See, put x is equal to 5 by 2, 5 minus 5, 0. So h tends to 0. Therefore, limit h tends to 0, k into cos x. What is x value? 5 minus h by 2 is equal to x. Therefore, put x is equal to 5 by 2 minus h by 2. by pi minus 2x is equal to x is equal to 3. Cos 90 minus h by 2 sin h by 2. So limit extends to 0, a into sin h by 2 by denominator h by 2 multiply 2 and divide 2 is equal to 3. So sin theta by theta tends to 0, 1. Therefore k by 2 is equal to 3, k is equal to 6. And also another important problem, 30th. Right, 30th question. Say 30th. F of x is equal to 5. If x is less than or equal to 2, ax plus b. If 2 is less than, x is less than 10 and 21. If x is greater than or equal to 10. So it is continuous. Find the values of a and b such that the function defined by is a continuous function. So write limit 2 minus and 2 plus and 10 minus and 10 plus. Limit extends to 2 minus f of x is equal to limit f of x 2 plus 2 minus f of x, and also limit extends to 10 minus f of x is equal to limit extends to 10 minus limit extends to 10 plus f of x. About 10 or below 10? Below 10. Below 2 this value is 5 and limit extends to 2 plus ax plus b. So now put x is equal to 2 plus x. Put x is equal to 2 plus x. As x tends to 2, x tends to 0. Therefore 5 is equal to limit x tends to 0, a into 2 plus h plus b. That is 5 is equal to 2a plus b. This is equation 1. And 10 minus limit x tends to 10 minus ax plus b is equal to 10 plus 21. So again put x is equal to, this is 10 minus, put x is equal to 10 minus x. As x tends to 10, as x tends to 10, S tends to 0. So limit S tends to 0, A into 10 minus H plus B. Limit H tends to 0. Then A plus B is equal to 21. So now equate solving 1 minus 2, not 2 minus 1. 88. 21 minus 5, 16. So A is equal to 2. So from equation 1, not to anyone. So 4 plus B is equal to 5. B is equal to 1. And that is also important. Understood? Remaining practice. If any doubt, once ask. bye.